There are three types of streams in nature: perennial, intermittent, and ephemeral. Perennial streams always have flows, with the low flows sustained by permanent baseflow. Intermittent streams have flows only a few months out of the year, with the low flows sustained by seasonal baseflow. Ephemeral streams have flows only during and immediately following rainfall. The location of the groundwater table, above, at, or below the river bottom, determines whether the flow is perennial, intermittent, or ephemeral, respectively. The depth to the water table varies across the climatic spectrum from arid to humid regions. In humid regions, the water table is close to the surface, while in arid regions it lies at much greater depths. In general, the drier the climate, the greater the depth of the water table. Therefore, ephemeral streams are common in arid regions. Erosion and sediment transport peak at a mean annual precipitation of 375 millimeters, which corresponds to an arid region. Thus, streams in arid regions are likely to carry significant quantities of sediment. From a geomorphological perspective, when streams carry a lot of sediment, their aspect ratio, that is, the ratio of width to depth, is large, typically between 50 and 100. Thus, river crossings in arid regions pose significant design challenges. The issue is how to provide a crossing in a wide ephemeral river channel effectively and economically. Bridges can be of many types and shapes, but they must span all or most of the stream width. Not spanning the full stream width in order to save construction costs can lead to loss of hydraulic performance. In such cases, the stream or river will eventually reclaim its full width, undermining the bridge foundation and endangering the superstructure. Excessive flow velocities near bridge piers and abutments is a common cause of local scour, which can lead to bridge failure. Bridges are usually built when traffic or the road network's importance justifies the cost. Most road bridges are permanent structures and are vulnerable to extreme hydrologic events. Rivers, particularly in arid regions, can significantly overflow their banks, spilling onto the floodplain. Additionally, floodplain rivers may change their course, defying the bridge's ability to perform its intended function. Fords are an alternative to bridges in cases of low traffic or lack of sufficient resources. Fords are engineered to cross the stream without a bridge when the flow is low or non-existent. In arid regions, fords are common in places where water flows only a few days out of the year. In some cases, fords have been built even in perennial rivers. The disadvantage of a ford is that it may not be operational a few times during the year, but when this is weighted against the cost of a conventional bridge, the choice is clear. Fords are common in rural areas and in developing countries where traffic is low or resources are limited. The ford bridge concept draws from the strengths of both fords and bridges. Bridges are permanent and costly. Fords may be temporary or permanent, but are comparatively inexpensive. Bridges are vulnerable to extreme hydrologic loads, while fords are generally able to resist most loads. Bridges are always usable as long as they do not fail. On the other hand, fords may be out of operation a few days per year. A ford bridge is a combination of ford and bridge, featuring most of the advantages and almost none of the disadvantages. The ford bridge works like a bridge during dry weather and like a ford during infrequent floods. A ford bridge in an ephemeral stream looks like a ford, but it has a relatively small bridge designed to pass the mean annual flood. The ford bridge can span the entire width of the river. There is no need to constrain the river in any way, and there are no bridge piers to scour during floods. Yet most of the time, usage of the ford bridge will be similar to that of a small bridge. Essentially, the ford bridge looks like a ford only when needed. At other times, the focus is on the bridge. Thus, for wide ephemeral streams in arid regions, particularly in developing countries, the ford bridge concept offers a unique combination of functionality and economy. The Arizona crossing, developed for use in the U.S. Southwest, is a type of river crossing similar to the ford. When a culvert is included, the Arizona crossing is similar in principle to the ford bridge. All bridge crossings are designed to sustain selected hydrologic loads. These are usually frequency-based floods, such as the 50-year or the 100-year flood. In a typical bridge design, the flood peak of a given frequency is expressed as flow velocities and used to calculate the scour at bridge piers. In contrast, a ford crossing has no piers. The only design requirement is the proper anchoring of the slab to reduce the possibility of uplift. As in the case of a bridge, failure of a ford under extreme hydrologic conditions remains a possibility. The components of ford bridges should be designed as fords and bridges, respectively. The ford component is pretty much the same as that of a conventional ford. The bridge component, however, is much smaller than a typical bridge. The bridge design criteria should be the mean annual flood, that is, the 2-year flood, widely interpreted as the channel forming flood. This is in contrast with the 50-year or the 100-year flood frequency used in conventional bridge design. The ford is designed to withstand infrequent floods, such as the 50-year or 100-year flood. The ford distributes the hydraulic load across the entire channel width. Thus, it is better able to sustain infrequent floods. The bridge deck, lying above the 100-year flood level, is designed to withstand the hydraulic loads. Given the right set of hydraulic and geomorphological conditions, the ford bridge affords a practical alternative to a bridge or ford. It is applicable to wide ephemeral streams, particularly in rural areas where traffic is light and resources are limited. Its design optimizes the occurrence of hydrologic loads, using the bridge for floods up to 2-year frequency and the ford for floods up to 100-year frequency and higher. Thus, the concept of ford bridge is an effective solution to river crossings for arid regions in rural areas around the world.